Hey everyone, this is Nick. I'm making a point-and-click survival horror game set in the Arctic where you are fishing for king crabs to pay off your debt to the feudal state, and it's called Crabmeat. You can check it out on Steam, but today we're going to talk about water. So, the game, set in the ocean, has a lot of water, and for the longest time I've been using this custom shader that I wrote. I wasn't really happy with how it looked, a lot of issues with it. It was really flat. I've kind of cheated this old version. It uses a rim light to try to give it a bit more shape. I didn't feel like it was sort of rough enough and wavy enough. And it didn't have other things, like we didn't have any sort of particle foam emitting over the edges of the waves. And we don't have a nice way to emit the actual like foam texture. Right now it just uses the height to do a comparison, which works okay. But sort of when you combine all these things together, it just feels unfinished. So what I was doing was started with a bunch of research. So I want to shout out two videos that I watched. The first one was the Sea of Thieves SIGGRAPH talk and GDC talk. Actually, I watched both. It was the art direction talk and the SIGGRAPH talk, going over basically the process of how they made their water. And then the second one was a YouTuber. I'm going to put it here because I can't remember. But they basically ran through how to implement compute shaders in Unity. And it was actually the first time that I've done a successful compute shader implementation. I didn't end up using their exact algorithm for the water, but I found that their explanation definitely gave me the foundation that I needed to actually get this thing moving once it came to optimizing. So before I dive into actually how we went through it, and I'll step by step, I want to show off some of the limitations that we have, right? So Crabmeat is a big world where we have tons of water, but we want it to run fast, right? Because it's pretty much always going to be on screen, so no matter what. We have lots of water. We have to do things like in certain regions, we apply these like regional tints. Again, this is all the old version. This all worked. So we have to keep this stuff. We can't change it. And then some regions, like over here, for example, we actually lower the intensity of the water, so it gets flatter. We have dynamic weather that has to interact with the water, so that couldn't get broken. And we have another feature. Currently, I'm not happy with the implementation, but as the boat drives, it does leave a weight in the water. And this is actually reused in a few other places. So I wanted this generic weight system to be maintained and ideally even look better. So those were all kind of the goals I had in mind when I wanted to do this update. So the first thing was, I knew that foundationally, if I could reduce the poly count of the water, so we already used tessellation, and the mesh right now is in the old version was a fixed mesh that tessellates based on the distance of the camera. And I actually have it is already pre-tessellated to be a higher density near the playable area of the game, and then lower density further away, because you know we see that. So, but in my head, I thought, wouldn't it be better to have a mesh that could follow the camera, and it'd be a much higher density again, but only have it in front of the camera, so like a cone or a frustum sort of shape. The problem with that was the way we were doing the water in the shader. I couldn't move the mesh. My math was all wrong, so that had to get fixed. So let's take a look at where the water is today. I think it'll be a lot easier to just sort of reverse engineer it from there. So first off, it turned out that the shader tool I was using, Amplify Shader Editor, actually already had a translucency solution. So I basically just cut the initial Fresnel, retuned the colors, and then enabled their translucency subsurface scattering, and tuned that up with the lighting, which worked really well. Secondly, I did the mesh optimization. So once we were able to convert all the math back from local to world space to true world space, we now have a mesh that follows the camera, and that mesh sort of accurately represents the camera shape itself. I still have a full version that I can use for debugging, but you can see the mesh is really big, but density is much more optimized. So the density is sort of approximately camera frustum. Now this could be improved again to be better reflective of perspective warping, but that more or less covers what the mesh looks like. So as we get closer in, that mesh tessellates more and more, and the relevant pixels are like quite high. Why go through all the effort to get more polys? Well, that was because I wanted to basically have more detailed water. So I rewrote the water Gertzner waves. Now I was already using Gertzner waves before, by a fixed set of properties on the shader. So now the waves aren't really controlled by the shader at all. They're controlled in C# by these wave structs, and then they are passed into the shader at global parameters. And that's secondarily useful because I have to call into those waves elsewhere. So by breaking it up and making it into an array, I was able to easily scale it. So previously I only had 3 wave levels. Now I have 5. We can go up to 6. There's really no limit. It's more a performance thing. You don't want to just have infinitely more detailed waves, even that is how close to an ocean. At a certain point, you'll sort of see diminishing returns. Another big issue was that turns out I was just calculating the normals of the ocean just totally wrong. So now I'm both correctly calculating the tangent and the normals from the waves, passing that through the vertex shader, and then also getting a better secondary surface normal on top, which gives us a little bit of a nicer effect. And if we bring this is in the shadow, this is basically the worst case scenario. This is where the light is hitting it, but from the view angle the camera ray doesn't appear to be. I would like to see if that can be modified, but I might have to modify the compiled shader code of Amplify, which I'm not really excited to do. The other thing we're able to do is calculate, this is based on the Sea of Thieves talk, calculate a Jacobian term. It's not math that I fully understand, but I found the algorithm and converted it. And that just gave me slightly better foam look on the top of the waves. Other thing it provided was a really nice property that I could then use when sampling the waves in VFX graph. So, similar to the camera and the ocean, we've also got a particle system that follows the camera, but it is not a sort of shuriken particle, it's a VFX graph particle system. The VFX graph side of it is actually quite simple because I'm basically just spawning a bunch of particles and emitting them up in the world with a bit of a direction. But a lot of the math is happening under the hood because I needed to call into our Gertzner waves directly. So it turns out you can just call custom HLSL nodes. So the ocean particles have their own little helper scripts where they are able to sample the wake from the boat. They're able to sample the waves. And they don't do as many samples as the ocean does. They just do enough to get the rough position. They're able to get the Jacobian term, use the composite of the waves and the wake, and determine whether or not the particles should be alive. It's quite strange because you need to basically emit like a lot of particles and then turn a bunch of them off. The final tricky thing was over their lifetime, the particles need to clip and intersect with the boat. So we needed to mirror a similar thing that the ocean was already doing, where in order for the ocean to not render inside the boat, we just basically have a texture that represents the boat, which is just hand authored. It's not a render texture or anything clever. And that is then used both to push that down, but then also sampled by our particles to stop them clipping with the boat. So as they get closer to the boat, or if the boat's moving through the particle chain, they will get clipped away. It's not perfect. There are issues where let's see if we can get it to happen. There are issues where they'll sometimes intersect with the front of the boat or with the rear of the boat, but generally I think it looks pretty good. So another thing to point out here is we took that initial wake system and I made it look quite a bit better. It both actually it uses the same nicer material that I created for the wake that I use on the foam layer, so it just looks better as a wake, but then it also emits significantly more particles to do the sample, and so it gets a little bit less of a ringing effect, and it also actually displaces the water, which previously it wasn't. Previously it was just painting into the texture. The displacement is pretty rudimentary, and I can jump to our test scene to show how that's done. So I determined that in order to get the water both optimized and get a lot more data packed into it, I went with the compute shader route. So initially I was attempting to use the reference video to do a nicer wake, but I kept my initial method where it's essentially the boat and anything that wants to generate wake has a ring buffer of points that it spawns every frame, and those fall off over time. And in the compute shader, we're basically painting to a texture using that ring buffer, and we also apply noise at that step as well, so that what we're rendering here is just exactly what the compute shader looks like. There's a couple of artifacts, like you get this very visible sort of ring effect, which I would like to resolve at some point if I can, but otherwise it works pretty well. The second thing is that was only one channel, so we have a render texture of 4 channels. So what I decided to do was actually use it to sample our fishing zones. So in the initial version of the water, I showed that the water needed to render these circular zones or crab locations. So now they no longer preview runtime because they're not being sampled by every single pixel at all times. they are just sampled because the player can never get that high out of the boat. In the previous version, we would have seen them out in the distance at all times, but because the player's camera never gets this high, not even remotely, the player's camera at most is on the upper deck of the boat, facing out into the ocean. We don't have to worry about those extremely high glancing angles that they could potentially see these things far off in the distance. We only really have to deal with sort of a rough approximate area of about 500 meters at most. Turning off some of these gizmos so we can see there's a zone there. As we get closer to it, you can see it's rendered in. And you can see also the trail being painted in the same texture. Overall, I'm quite a bit happier with how it looks now. It looks nicer. It handles more conditions better. It generally just provides that sort of feeling of ocean much better. I think it handles like deep, scary ocean really, really well. This weather effects already existed. This is just the exact same parameters, more or less, that I had before, just applied to a better quality lighting model and displacement model. And then, yeah, just generally think it looks a lot better. Oh, we're gonna crash. So if you want to find out more about the game, please join the Discord. The link will be in the description. We will be doing a demo for the game really soon. So please wishlist the game or join the Discord. You'll find out when it's coming out from there. And yeah, I look forward to sharing the actual final game with you soon.